log of Zn plus 2 has a value 10 raised to the power minus 1, and Sn plus 2 has a value 0.01 can be written as 10 raised to the power minus 2. Now you can easily solve it. 0.62 minus 0.059 upon 2, and when this denominator will go in numerator, it will be positive and it will be equal to 10. And now log 10 has a value 1. Log 10 has a value 1. Now you can easily solve it. 0.62 minus, I am going to round it off, it will be equal to almost 0.06 upon 2. Sorry, I was disconnected. Is your screen shared? So it will be 0.62 and it will be cancelled. 0.03. Now you will get your answer after solving this. Please write it and let me know when you are done with this.
Yes, sir, finish.
Very good. Very good. So now we are going to start a new topic, that is electrochemical series, and it's very easy. Sneha, are you done with this?
Yes, sir.
Okay, thank you. Now see, this electrochemical series is very important. Electrochemical series. In short form, I will write ECS, electrochemical series. So first I am going to write the series: lithium, potassium, barium, strontium, calcium, sodium, magnesium, aluminum, manganese, zinc, chromium, iron, cadmium, cobalt, nickel, nickel, tin, lead, and then hydrogen. Why I am writing so? You will get it. copper, and then iodine, then Ag, Ag is silver, Hg, mercury, bromine, platinum, oxygen, chlorine, gold, and then fluorine. Please write all this and then let me know. Then I'll start explaining. It's very easy. We don't need to learn it. We don't need to remember this value. You will know what you will get to know what we are going to do with this.
Yes, sir. Finish.
Very good.
Sir, what's after Fe, iron?
After Fe,
Yes.
it's Cd, cadmium.
Okay, yes, sir.
Got it?
Yes, sir.
Everyone done with this? Now see, basically we have, first of all, before this, we have a standard SHE, sheet. And SHE stands for a standard hydrogen, a standard hydrogen electrode, a standard hydrogen electrode. So basically, at cathode is negatively charged, so positive ion will get there to H plus. It will get gain 2 electron and it will be converted into H2. And at anode, we know that anode is positively, this is negatively negatively charged electrode, and this is positively charged electrode. So at anode, there will be oxidation and it will be half H2, or we can write, since we are going to balance it, so I'm going to write it 2H plus 2 electron. Always remember this. In the previous lecture, I have already taught all this, that at anode there will be oxidation and at cathode there will be reduction. The main important point is that we considered 12 E naught R will be 0 here and E naught R will be 0 here. See, electrochemical series, this series basically is based on the value of electrode potential, and the value of electrode potential of all these elements are calculated with reference to hydrogen, and the hydrogen we take the reference element hydrogen, E naught R of hydrogen, always remember that, equals to 0. And we calculated all the electrode potential of all the elements with reference to this. Now I have written this in decreasing order. This is most negative E naught value, and this is most positive value of E naught. Now the difference is that this is most negative, and down the group the negative value magnitude decreases, and then again decreases, then comes to 0, and after 0 it is positively increasing. And on this base, basically after the given value, we can predict whether which element or which species is more oxidizing or more reducing, or which can easily oxidize or reduce. So I'm going to write all this, this and this both. E naught value is positive. E naught value is positive. E naught R. Now, if we are going to see about this and this, E naught value, E naught R will be negative. E naught R will be negative, and hydrogen has a value which is 0. So its application is very important. First of all, I'm going to write the characteristic of each, that is electrochemical series. It's very important. So please write it.
Yes, sir. Finish.
Neha, are you done with this?
No, sir, just a second.
Okay.
Done, sir.
Now, characteristics of ECS. Electrochemical series. So first of all, the value of E naught R of hydrogen will be equals to 0. The value of E naught R, if in questions needed, it won't be given. You have to remember it. Now the next point is elements lie above hydrogen have E naught R equals to positive. Now the third point, elements lie below hydrogen have E naught R equals to negative. According to my series, in NCERT, a positive value of E naught R is given first and then 0 and then negative. But in my table, you can see negative value, then 0 and then positive. Got it? Now the next point is very important. Top to bottom. Always see top to bottom in my series. Top to bottom, E naught R increases. E naught R increases because on the top it is highly negatively. Okay, okay, and then decreasing in negative, then comes to 0 and then positively increasing. That means top to bottom in this series that I have written is E naught R value increases. Fifth, lithium most negative. Lithium most negative and fluorine most positive. Fluorine most positive. So it is very important. Please write it. Then we will talk about application of electrochemical series.
Yes, sir. Finish.
Please write it.
Yes, sir. Finish.
Very good. Now application of ECS. Electrochemical series. So first is basically reducing and oxidizing agent. So when we move from top to bottom, you have to be careful about the value. In the top, negative value is more. If I will ask you -2, -4, which one is greater?
-2.
-2 is greater. So you have to be careful about the value. When we move top to bottom, reducing reducing power, reducing RP, reducing power, decreases, reducing power decreases, and oxidizing power increases, and oxidizing power increases. So if you have value of E naught which is greater, that means that have lesser reducing power and more oxidizing power. Are you getting my point? If X has
Yes, sir.
-2 volt and Y have -3 volt, which one will have -3 volt? Which one will have more reducing power? X or Y?
X.
X1 will have more reducing power because it is less, the value is, you can see the value is greater. You can see
Yes,
from
sir.
top to bottom it will be -3, then -2. So it will
Yes.
have lesser reducing power, not more reducing power. Sneha and Nafisa, don't be confused. It's basically there is confusion always in between the students. When we are moving down the group, the value slightly increases, and if the value increases, that means reducing power decreases and oxidizing power increases. Are you getting my point, Sneha, Nafisa?
Yes, sir. Yes, sir.
Okay, I'll give you a lot of question. It will be clear. That means if E naught R value increasing, then oxidizing power increases, reducing power decreases. Now next, reactivity, which one will be more reactive and which one will be less reactive. So top to bottom decreases, top to bottom decreases. Please write it.
Yes, sir.
Both of you done with this?
Yes, sir.
Yes, sir.
Very good. Now, the next application is very important. Metal. In metal displacement reaction, we use this value to predict which one will be displaced and which one will not be displaced. So the third application is metal displacement. So when we talk about metal displacement, so the metal which lie above in ECS can displace Oh, sorry, I was disconnected. Now you can see the metal which lie above in ECS can displace the metal from its salt which lie below in ECS. That means you can see, it's very important to learn that iron can easily displace cadmium. The simple word sentence, the metal which lie above in ACS can displace the metal from its salt which lie below in ECS. Now you can see copper is here, and where is zinc? Zinc is here. Now you can see zinc can easily replace copper, but copper cannot replace zinc. So if a metal is present above in ECS, that can easily displace the below metal from its salt. Like if I'm going to take an example, zinc plus CuSO4 will be ZnSO4. Copper is displaced from its salt and Cu. Now if you are going to react Ag plus FeCl3, no reaction, because iron lie above Ag. That's why this reaction will not take place. Okay, is that clear?
Yes, sir.
Please write it.
Sir, can you explain the second example again?
Now you can see if you are going to react this. Okay, now see where is Ag in the electrochemical series and where is iron. You can see Ag is here, and where is iron? Iron is present here. That means iron is above Ag. And what was the theory? If a metal can displace another metal from its salt, when that metal will present above in the series, this iron can replace Ag, but Ag cannot replace iron. Are you getting my
Yes,
point?
sir.
You can take example
Understood.
of this K. K can replace sodium, but sodium cannot replace K, potassium.
Yes, sir.
Okay.
Okay.
Very good. Now, the fourth application is non-metal displacement reaction. Non-metal displacement. Now, the theory will be opposite. The non-metal which lie below in ACS, which lie below in ECS, can displace the non-metal from its salt, which lie above in ECS. So it's very easy to understand. In metal displacement, above element can displace the lower element from their salt, but in non-metal displacement, below element will displace above non-metal from its salt. Like if I'm going to take an example, Br2 plus Ki. Ki is above Br, so Br can easily displace I. Br can easily displace I. But if you are going to react this I2 plus KCl, there will be no reaction. Please write it.
Yes, sir. Finish.
Very good. Both of you done?
Yes, sir.
sir.
Very good. Now I'm going to give you a question. Always remember that. Always remember that if E naught R value increases, the value will be given. E naught R, that means I have written like E naught R. The value of E naught R increases, that means reducing power decreases and oxidizing power increases. You can easily see the value, and you can easily plot whether which one have higher value and which one have lower value. Now the question given CO plus 3 plus electron will give you CO plus 2, and it has a value E naught will be equal to plus 1.81 volt. PV plus 4 plus 2 electron will be PV plus 2, and E naught will be equal to plus 1.67 volt. C plus 4 plus electron will give C plus 3, and E naught will be equal to plus 1.61 volt. Be careful while solving this question. B plus 3 electron. It doesn't matter how many electrons it gains. It matters what is the value of this E naught. Are you getting my point?
Yes, sir.
And E naught value is, wait a minute, plus 0.20 volt. Write in increasing order of oxidizing power. Please write.
Sir.
Yes.
Sir, so the order will be the same because you said that if
Which
E,
one will have the highest value? Or which one will have the most oxidizing power?
the first one,
The
because
first
it
one,
has
because
more.
E naught R value increases, oxidizing power
Yes,
increases.
sir.
So if I'm going to write it in increasing order, CO plus 3, and then PV plus 4, and then
Yes, sir.
C plus 4,
CE plus
and then
4.
BI plus 3.
Yes.
Sneha, what about you? E naught R value increases, oxidizing power increases. So the most value will have the most power to oxidize. Yes or no, Sneha? Sneha, please do reply.
Yes, sir.
Very good. Can I change the slide?
Yes, sir, I'm done.
Yes, sir.
Okay, thank you. Now the next question. Given that E naught O2 slash H2O will be equal to plus 1.23 volt, E naught S2O8 minus 2 slash SO4 minus 2 will be equal to 2.05 volt, E naught Br2 slash Br minus will be equal to plus 1.09 volt, E naught Au plus 3 slash Au will be equal to plus 4 volt. The strongest oxidizing agent is, I'm going to give you option Au plus 3. Please write the question. O2. S2O8 minus 2. Br. Please do this.
Sir, option C.
Very good. What about you, Sneha? Please answer me in chat box, Nafisa.
Yes, sir.
Sneha, let me know if you have any doubt in this. Again, the same E naught R value increases, oxidizing power increases, and reducing power decreases. And we need to see the strongest oxidizing agent. So which one will have the highest value? This. So the answer will be C. Sneha?
Yes, sir.
Is there any doubt in this?
No, sir, I got the answer.
Very good, very good. Thank you. Very good. Oh, wait a minute. Okay, next question. Consider the following reduction process. Consider the following reduction process. Zn plus 2 electron will give Zn solid. E naught has a value minus 0.76 volt. Ca plus 2 electron will give calcium in solid. E naught has a value minus 2.87 volt. Mg plus 2 electron will give Mg in solid, and E naught has a value minus 2.36, and Ni plus 2 electron will be converted into Ni solid, which has a value E naught will be equal to minus 0.25 volt. Now what we need to calculate is write in increasing order of reducing power. Please write it.
Sir,
Yes,
calcium and then magnesium and then
which one will have the highest value or highest
highest
reducing
one
power?
Ca,
What? Ca, calcium,
and
and
then
then
magnesium,
magnesium lesser, and then
and then
zinc.
Ni, zinc, and then yes, sir.
Right. What about you, Sneha? Very good. Please let me know whenever you have any doubt, both of you.
Yes, sir.
Now, the next question given E naught Cl2 slash Cl minus will be equal to 1.36 volt. E naught Cr plus 3 slash Cr will be equal to minus 0.74 volt. It is also given that E naught Cr2O7 minus 2 slash Cr plus 3 will be equal to 1.33 volt. It is also given that E naught MnO4 minus slash Mn plus 2 will be equal to 1.51 volt. Among the following, the strongest reducing agent. The strongest reducing agent is, I'm going to give you an option, Cr, then Mn plus 2, then Cr plus 3, then Cl minus. Please do this carefully.
Sir, it would be C option.
Is it C or A? You have to be careful.
Yes, sir. It's the minus negative
See,
0.7.
we need to see a strongest reducing agent. If you are going for E naught, a strongest reducing agent will have E naught R lesser, because I already told you that if it is
Yes, sir.
increases, oxidizing power increases and reducing power decreases. Simple.
Decreases. Yes, sir.
So you can see reduce the one which has the lowest value of E naught R. And again, reducing agent means oxidizes itself. Oxidizes itself.
It's
So which one will oxidizes? CR will oxidizes
yes, sir.
into CR plus 3. That's why it is CR. Okay.
Yes, sir.
CR
I
can
thought it was.
oxidize
I
into.
thought you wrote that option for C. I thought you wrote the CR for this one, C. So I said C. I meant to say that. The yes, sir.
Okay, no problem. Sneha? Sneha got it? Thank you. Now the next question is, given E naught CR plus 3 slash CR is given as minus 0.74 volt and E naught MnO4 minus slash Mn plus 2 will be equal to 1.51 volt. Again, E naught Cr2O7 minus 2 slash Cr plus 3 will be equal to 1.33 volt. Again, E naught Cl slash Cl minus will be equal to 1.36 volt. Which one is the strongest oxidizing agent? A is chlorine, B is Cr plus 3, C is Mn plus 2, and D is MnO4 minus. Please write it.
Sir,
Yes. Yes, Nafisa.
sir would be
What did we?
sir. Isn't Mn plus 2 and MnO4 in the same? I'm
No,
confused.
since it is asking you oxidizing agent, that means reduce itself. Yes or no?
Yes, sir.
So you have to be careful. Here the oxidation state is plus 2. Can it reduce itself, and here it is plus 7. So which one will reduce itself?
Uh,
+7.
D. Yes, sir.
So the answer will be D.
Yes, sir.
Got it?
Yes, sir.
Sneha, what about you?
Yes, sir.
Very good. The standard reduction potential values of three metallic cations are 0.52, -3.03, and -1.18 volt, respectively. Write in decreasing order of reducing power.
Sir.
Yes. Which one will have the highest reducing power?
Highest reducing power would be Y minus
Y.
3.03, and then after that
Z.
Z, and then
And then
X.
X. Sneha, have you got the same answer? Sneha? You are not audible. Now I'm going to start a new topic. Sneha, do you have any doubt in this? Okay, thank you. Very good, Sneha. Now, we are going to see electrolytic cell. Electrolytic cell. So in a container, we have cathode and anode. This is a container in which there is cathode and anode. This is anode and this is inert electrode, that is platinum or graphite, and this is cathode. So this is negatively charged and this is positively charged, and there is a solution in this container. Now this solution varies whether you are taking the solution in molten state, aqueous or diluted state. So first of all, in the first case, I am going to take molten state. Now we have molten NaCl. Molten NaCl. That is molten NaCl. That means it is in semi liquid type. So whenever it is in molten NaCl, it will be dissociated into its ions. That is, NaCl will be dissociated into Na plus Cl minus. Now you can see, if there is ions Na plus and there is ions of Cl minus, you know the nature, opposite charges attract each other. So Cl minus will go to positively charged and Na plus will go to negatively charged electron. Yes or no?
Yes, sir.
Cl minus ion will go to positively charged and Na plus will go to the negatively charged electron. Now we have at cathode, Na plus will go and Na plus will gain one electron from the cathode and it will be converted into sodium Na solid. Now you can see at anode, Cl minus will go and it will lose one electron and it will be converted into half Cl2 gas. Half Cl2 gas. It will lose one of its electron at anode. Now the important thing is product of electrolysis. Product of, wait a minute, product of electrolysis. So when we say product of electrolysis, so Na solid deposited at cathode and Cl2 gas evolved at anode. So there will be a question like this: electrolysis of following molten state is going on. What will be the product on which electrode sodium will be formed or sodium will be deposited? Questions will be like this. So please do it. I'm waiting.
Yes, sir. Finish.
Both of you done?
Yes, sir.
Sneha, let me know. Okay, thank you. Now this was the example of molten. Now I'm going to take an example of aqueous NaCl. In aqueous NaCl, basically there is a large amount of water also as compared to molten state. So if we have NaCl in aqueous, it will be dissociated into Na plus plus Cl minus. Cl minus. And H2O is also in a good quantity. So it will be also dissociated into ions like H plus plus OH minus. So basically there are two ions, there are two positively charged and there are two negatively charged. Now we have to decide which one will go to cathode and which one will go to anode. And that we will do with the help of preferential discharge theory. Preferential discharge theory. So first of all, there will be two cases for cation as well as anion, positively charged and negatively charged. So case one for cation. For cation. If I'm going for cation, E naught R, if E naught R increases top to bottom, you know that top to bottom in that series, top to bottom, E naught R increases. That ion will migrate first. That ion will migrate first. So it is clear that if there will be two elements like here you can see Na plus and H plus, which one will go to cathode? So basically which one will have higher value of E naught R will go to cathode. Is that clear? Sneha, Nafisa?
Sir, can you say it again?
So what I just said, see, we took aqueous solution. So aqueous NaCl, that means NaCl, and there is also a good quantity, pretty good quantity of water also. So NaCl will be dissociated into Na plus Cl minus. In molten state, the quantity of water is not that much that we consider. But in aqueous solution, we consider H2O because its quantity is good, more. So H2 will also be H plus and OH minus. Now you have two electrode. This is positively electrode and this is negatively electrode. Now positive has two options in which one of them will go to cathode. One of them will go to cathode, and negative also have two options. One of them will go to anode. So which one will go to cathode and anode? This will be done with the help of preferential charge distribution theory. Discharge theory, preferential discharge theory. So there are two cases for cation as well as anion. For cation, if the value of E naught R, one of them, if the value of E naught R for both of them, you can see like if we have two options, Na plus and H plus, we will go by the value. If E naught R value of greater, whomever the value of E naught R is greater, that will migrate first, that will go to cathode. Got it, Nafisa? Na plus has negative value, Na plus has negative value, H plus has zero value. So E naught R of H hydrogen is greater than Na. That's why H plus will go to cathode, not Na plus. Is that clear?
Yes, sir.
So basically at cathode, H plus plus electron will go to half H2 gas, half H2 gas. Now please write it, then I will go for the next concept, negative ion, for an ion.
Okay. Loaded. Finish.
Let me know when you are done with this.
Yes, sir, finished.
Very good. Now, case 2. For negative ion or for anion, we can call it for anion. You can see age of migration. Age of migration. SO4 minus 2 will have the lowest age of migration, then NO3 minus, then OH minus, then Cl minus, then Br minus, then I minus. So at anode, you can see at anode in aqueous NaCl, we had two options. OH minus and Cl minus. For aqueous solution, OH minus and Cl minus. So we just have to compare which one will be easily migrated, Cl minus or OH minus. Cl minus. That's why at anode, Cl minus will go to half Cl2. For balancing, I am going to multiply it by half, and one of electron will lose by Cl minus. Now, product of electrolysis is important. Wait a minute. Product of electrolysis. So when we do product of electrolysis, you saw that H2 gas evolved at cathode. Now the next, which is very important, Cl2 gas evolved at anode. Again, if you have seen that there was 4 options. NaCl converted into Na plus Cl minus. Now concentrate here H plus and OH minus. H plus and OH minus. So you can see H plus converted into H2 and Cl minus converted into Cl. Now in the solution, Na plus and OH minus left. So this both will combine and form NaOH in the solution. That's why nature after electrolysis will be basic. Please write it. Wait a minute. Let me know when you are done with this.
Yes, sir. Finish.
Sneha,
Yes, sir.
both of you done?
Yes, sir.
Yes, sir.
Now I'm going to give you a question like if we have aqueous USO4, if you have aqueous USO4, you need to tell me at cathode the product after electrolysis at cathode and anode. In the previous, I took the example of aqueous NaCl. In the same way, you have to tell me the product after electrolysis at cathode and anode. Can you do it, Sneha and Nafisa?
Yes, sir.
Okay, I'm waiting.
Sir.
Yes.
CuSO4 will become Cu plus SO minus 4.
See, I'm going to just give you an example, solve it. You are going to match it. Since it is in aqueous, that means H2 will be also there, and there will be H plus OH minus. Yes or no?
Yes, sir.
So we have anode, that means positively charged, and we have cathode, that means negatively charged. Now these are two positively charged. Now you have to see whether which one of the following will go to cathode. So whenever we are going to work for cation, you have to see the value. You know, E naught R for hydrogen is basically 0, but E naught R for Cu plus 2 is something positive. We don't know the exact value. I don't remember the exact value, but it is positive. So Cu plus 2 will go to cathode. So at cathode, what we get, Cu plus 2 will go and gains 2 electrons from cathode, and it will be converted into Cu solid. So at cathode, Cu is deposited. What about anode? Now we have two options also. SO4 minus 2, OH minus 1, OH minus. So SO4 minus 2 is of in the list of ease of migration, it was in the last. So OH minus will go here. Now OH minus will go and you know what it will form. whenever there will be OH minus, it will go and form H2O plus O2 and gains release some electrons. So you are going to take 4OH minus and H2O 2H2. It will always oxidize into O2. OH minus will always oxidize into O2. This H2O will be in solution, but at anode, O2 will evolve. O2 will evolve. So please write it. Is it the same, Nafisa?
No.
Okay. What about the cathode? Cu plus 2 and H plus. For cation, I had already told you that cation we will go by E naught R value, and for anion I just wrote the series of ease of migration. Please let me know when you are done with this.